My name is Brandon Keepers. I work for a company called Ordered List, and today I'm going to talk about something that we're all somewhat familiar with, bad software. So as you're getting ready to do anything in life, it seems like everybody's always willing to give you advice. And so as I talk to people about, oh yeah, I'm going to be speaking at this conference, two things like everybody kept saying, like, you got to be funny. You know, if you're not funny, then people will stop paying attention. And second, you have to use some kind of meme in your slides, so either pictures of cats or the why you know guy. So I thought I would go ahead and get that out of the way right now, and then we can get on to the content. So I'm from like up north, like Michigan, where it gets cold and freezes in the winter. So this weather is hot. I can't handle it. I'm Beekeepers on Twitter. I'd love to hear your feedback or thoughts on this presentation. I by no means know everything about bad software. I'm good at writing it, but that's about all I know. So feel free to let me know what you think. I also blog at opensoul.org if you want to follow along with some of the things I've been working on or thinking about. So today I'd like to have a little bit of a group therapy session. It seems like this is a topic that we all love to complain about. So if this is emotional for some of you, you're welcome to come up afterwards, and I can give out some hugs or whatever you need. All right, so let's get on. Oh, crap. Okay, we're good. So about a year ago, I had this realization. Everywhere around me was really bad software, and not only like this kind of stuff that we like to complain about, but like the world runs on bad software. Like the software of the systems that we use every day is surprisingly fragile compared to other public infrastructure like highways or buildings. And these are all systems we love to, or all systems that we completely depend on. And like I said, this is a topic that we love to hate. We all have stories about bad software. So if we can, let's start. Let's see who has the worst experience with software. Who thinks they have the ugliest app that they're maintaining? Anyone? We got a couple hands. Okay, someone prove it to me. Tell me about your app.
3,000 line functions.
3,000 line functions. Wow. What about interface? Does anyone have a really ugly interface? What interface? Who thinks they have the ugliest? I need one person. All right. Twilio? No, you guys don't have the ugliest.
I work for the federal government.
Oh. All right.
We had a piece of software that was managed by 18 different agencies.
Ooh. Well, I have something for you to take back to them. This is a certificate of bad software. You can tell them that their software is so ugly that their users vomit so they have something prettier to look at. So come up and grab this. Thank you, government. So this realization of bad software is something that was kind of hard for me to swallow. I mean, I take a lot of pride in what we do. Our industry may have started with underwear-veiled hackers in mom's basements, but I like to think that now it's kind of grown up. We've become professionals, and now we're valued members of the world that everybody depends on. And me, like probably many of you, consider myself somewhat of a craftsman. I don't do this job because it pays the bills, although that's nice. I don't do it just because I'm good at it and there's nothing better to do, but I actually do it for the art. Like, I love software, I love code. I love the difficult challenges, the ones that you feel like you're not going to be able to solve, and then all of a sudden you somehow crack it. So for me, I'm motivated as much by reputation and what other people think of me as I am the desire to impress myself. So like I said, I work at Ordered List. In Ordered List, we take great pride in our software too. We have a bunch of products out. Harmony app is a hosted website management system. And I'll try not to, I'm not trying to pimp my services or products here, so this is going somewhere. But Harmony is awesome. It's really flexible, really well architected. And so like we feel like it helps people build websites without all of the complexity of some of the other options out there. We've got Gauges, which is a real-time web analytics package. This app was a ton of fun to write. There's some really interesting problems. We have lots of data coming in. We wanted to roll up stats in real time. This is new. We just launched it earlier this year, and it's been going pretty well. And then we got Speaker Deck, which is something we have no idea how we're going to make money on and don't really care at this point. But Speaker Deck is, for us, we got frustrated with all of the slide sharing sites out there, so we wanted something simple and clean and beautiful. And then we spent the last year working on a project called Words with Friends. It's now owned by a company called Zynga. And when we came in, Words with Friends was struggling to scale. They couldn't handle the amount of traffic that they were getting. And so over the last year, we've worked with them to be able to handle nearly 1 million requests at peak load, which is actually quite a few. And then recently we launched a HTML5 version of their Scrabble-like game for Facebook. So I tell you all of these things not to, like I said, not to pimp our services or to try and impress you, but to convince you that I love good code. Like anyone that's worked with me knows that I become paralyzed anytime there's anything within the viewport that is ugly or nasty. It's quite a debilitating disease. So, however, even these things, the products that I just talked about and the clients that we've worked for, like as intentional as we've been about writing good code, none of them are perfect. In fact, they're far from perfect. A lot of them are really bad. Some of the code in there I'm very ashamed of. And so kind of realizing that I'm a part of this industry that produces bad software has been a little bit of a struggle for me. Once I got over the emotional trauma of that, though, I had this interesting thought process where I realized that, you know what, the world hasn't imploded. Well, yet. Hopefully it's not going to be our fault if it does, but the world actually runs on bad software. For the most part, there's not any major issues with it. Every once in a while we have the inconvenience, you know, flights getting canceled or something like that related to bad software, but we're actually doing productive things. And so it makes me kind of wonder, well, what would a world of good software look like? What would happen if we waited until the software was at whatever standard we expected it to be until we launched it? So that's kind of what I'd like us to explore a little bit more today. I think it's probably in spite of the bad software, I think it's probably because of bad software that we're where we're at. So today I want to look at this balance between pragmatism and perfection, and just see what that means for the way that we write our code. So we're going to start by looking at what is good software, how does it go bad, and what can we do to build better software. So let's start with my definition of good software. Good software meets the present objective at an acceptable cost without incurring an unacceptable amount of risk. It's kind of a lot of jargon in there, but basically it does what we want it to do, it doesn't cost too much, and we don't go broke or get killed in the future. I think another definition of that would be adequacy. It's adequate for the task that we're asking it to perform. And by this I don't necessarily mean mediocrity. Like, it doesn't mean that it doesn't perform well, but it means that it's adequate, good enough. So let's look at objective. One of the things that's hard for me to accept is that software is not code. Software is so much more than code. As a developer, it's easy for me to get stuck in the details and make sure that the code looks perfect without stepping back to think about, okay, what's the experience of this software like? A quote by Zach Dennis of Mutually Human Software: people fail to realize that quality is merely a property of the code that exists, not the reason for its existence. So as developers especially, I think this is something we need to keep in mind. Unfortunately, users don't care what the code looks like. I wish they did. I wish I could show them, look how beautiful this is. It works so well. But they don't care. They care that it works. Quote by Scott Berkun, "We're frustrated most in life by things that come close to our deepest needs but don't deliver." And I think that's really true. Like, if I think about the things that frustrate me the most, it's not the things that are buggy. Those are annoying, but you can learn to work around that. It's the things that just don't meet your needs. Next, let's talk about cost. Virtually all the cost of software is directly or indirectly the cost of design. So I think that's a really interesting idea. Basically for a tool or industry that's built around fabrication, which is really what software is, we're producing either tools or products that are then consumed by other people. We have almost zero cost of production. We have a little bit of expense in the laptops that we code on, the infrastructure that we use to run our services, but we don't have to manufacture parts or have the expenses involved with any of that. But design costs money. Writing code costs money. That's how obviously we're all here doing this professionally. We either get paid directly from clients, in the form of an hourly rate or a salary. So basically with software, what we do is we figure out what we want to build, we figure out the objective, and we keep iterating on it until we run out of money. And the hope is that by the time we're out, we have something that meets the objective that we started out to meet. So next let's talk about risk. I know that many people will probably disagree with me, but for me, risk is not a science. At the scale that we're doing things, which I think is smaller compared to federal government jobs or huge corporations, we don't have time to calculate the risks. We can make educated guesses, but essentially what we need to do, or the way that we do the math for this, if we want to lower the risk in the future, we have to increase the cost now. So what does that mean exactly? If we want to make sure that the software doesn't break at some point in the future, we're going to spend a little bit more time testing at deeper levels. Maybe we'll write unit tests, functional tests, and integration tests. So for us, this is the trade-off we're kind of constantly trying to make, but it's one of the aspects that I think goes into good software. So again, what is good software? It meets the objective at an acceptable cost without incurring an unacceptable amount of risk. So why does software go bad? I think the main reason is entropy. So entropy is this thermodynamic property. There's a lot of aspects to it, but mainly in an enclosed system, things will tend towards chaos. The pragmatic programmers say, while software development is immune from almost all other physical laws, entropy hits us hard. Why is that? I don't know. I have a couple ideas, but it seems like the hardest part of my job is making sure that things stay orderly. So my first idea for this is software is malleable. This is actually a really good thing. We have zero cost of production. We can write some form of code, see if it meets our needs, and if not, we can keep changing it. So we continue to morph the software as our requirements change, because change is really cheap for us. So we build something, we play with it, and then we change it. The hard part, though, is that every time we touch code, we have the chance of introducing some form of complexity. And unless we're really intentional about minimizing that, it'll eventually, it'll continue to descend into chaos until it feels almost impossible to recover from. The other hard part of this is when you get more and more people touching the code. So if you're the only one going through it, you can keep the entire system in your mind, and every time you go through it, you know what your intention was. It's easier to keep it clean. But as you add more and more hands, I might do it this way. Someone else comes along, they have a little bit different style, a little bit different idea of how the system should work. So a lot of people working on it increases the likelihood that it'll become more complex. So just out of curiosity, how big of teams are you guys working on? Is anybody working on a team of 5 or less? Wow, that's actually impressive. How about more than that? So like more than 10? Like 10 coders, 10 people committing to the code? 20? Looks like you're the winner. All right, I have another certificate for you. You have the Bad Software Award for too many cooks in the kitchen. Make sure you get those framed. So I think another reason that software so easily succumbs to entropy is because it's extremely complex. Every line of code is essentially a moving part. So if you think about some of the more complex things in the world, so like a car, to me, I have no idea how people can maintain a car. Mine's always broken. A car has 30,000 moving parts. It's not really that unlikely for a Rails app to have 30,000 moving parts. So I ran this on an app that ran rake stats on an app that we've been working on lately. It has 28,000 lines of code. Each one of those lines of code, if they're out of place or if they are somehow poorly structured, are a chance for the system to break. So we're just dealing with things that are huge magnitude compared to manufacturing a chair or a table or something like that. It's impossible to keep the entire system in your head. Another example, probably the most complex thing I can think of, which I'm sure there's worse things, but space shuttle. Space shuttle apparently has 2.5 million parts. I've heard of apps that have 2.5 million lines of code. This is extremely complex stuff here. Does anyone have an app that's that complex? No?
The shuttle has its own app with millions of lines.
Exactly. I mean, it's even worse than that, yeah. Does anyone have an app with more than 50,000 lines of code? A few? 75? 100,000? 200,000? Do I need to go in bigger leaps here? All right, back in the corner. Guess what? You get a certificate too. Bloated software. Woo! You want to come up and grab this? So another reason I think software goes bad is that what we do as an industry is actually really immature. In the grand scheme of things, we've been around. People like us have been around maybe 50 years. Whereas if you think of like math, sciences, other disciplines like that, they have a lot of history behind them. They have a lot of expertise and knowledge that's passed down. Some of it's changing, but none of it's changing as fast as our industry is. The other aspect of that is if I want to go build something physical, like if I want to build a bridge or a chair, I have to go through a process before anyone will trust me to do that. So I have to go to school. I have to learn all the tools of the trade. And even once I'm done with school, I have to climb the ladder enough to where I have enough respect to be able to design that and then get somebody to manufacture it. Software, we have people, we have teenagers writing code, which is awesome, but it also means that we don't have the shared knowledge that some of the other industries do. I think we're more open than other industries, so we share kind of in a more organic way, but we don't have the formal part of it that other industries do. So just in this room, let's find out who's the youngest person that writes code. Is anyone under 22? Anyone under 20? No? Are you 20? Is anyone younger than that? All right, we got another certificate. Congratulations for learning to tie your shoes. I hope there aren't any civil engineers that are 20 years old. No, but that's an amazing power that, at 20 years old, somebody can be working professionally building software. But with that, not to say that young people are necessarily the main culprits in writing bad software, but I think that's definitely one part of it. So the other reason I think is that software is opaque. Compared to things in the real world, most of software is hidden behind layers and layers of complexity. Very little of it is actually exposed. We might have some form of a thin user interface, but then most of it is not visible to anybody except for the people that wrote it. As long as each layer responds properly, the software can continue to get more and more chaotic. So we have these APIs that are defined, and as long as that method, given the same input, returns the same output, it doesn't matter what it looks like inside. And then I think finally the last reason is software is really durable. So even given all of these other things, given the rate of change, how malleable it is, it doesn't degrade over time. With physical things, if I made a chair that was in some way inadequate, it will eventually stop working. And software, as long as we're giving it the same input, it'll continue to give you the same output. You can call the same bit of code, no matter how messy it is, over and over and over, and it'll continue to work. Which that's actually kind of unfortunate. It'd be fun if it would actually degrade and then eventually just break. But I mean, in a sense it does, but like I said, as long as you're giving it the same input, you'll get the same output. There's the issue of bit rot, but I think that speaks more to maintenance than the performance of the software. So if I don't touch an app for 3 years and it's on Rails 1.2, it's a pain in the butt to bring it up to Rails 3, but that 1.2 app is probably still performing. I think actually I know of a couple 1.2 apps that I wrote that are still out there, and it scares me. But software just has an amazing lifespan. So I'm curious, who here is still working on code that they wrote 3 years ago? How about 5 years ago? Wow. 15 years ago? Seriously? 20? It's not Rails, no, that's fine. So 15, 16? 17? All right. Another certificate for you. You wrote code when dinosaurs roamed the earth. Congratulations. That's awesome. I mean, I was 8 years old when you started working on that code.
They were using computers that were built in the 80s at that plant.
That's awesome. So, I mean, I think that's a really interesting aspect of software. It's durable, and no matter how chaotic it is, it'll continue to perform. So, knowing all of this stuff, how do we build better software? How do we overcome some of these obstacles? I don't really have any great answers. I have a few things that I know that work for me. And that I think are important, and I know that these are only a few aspects. I think that there's a ton of other things that are important that we need to also do. The first one, though, we can't meet objectives unless we actually talk to the people that are going to be using the software. And I don't mean like send in some account exec and make a 20-page document that outlines it. I mean, as you're writing code, put it in their hands and watch them use it and let them react to it. Some of the most rewarding projects I've worked on recently are ones where I can write code in the morning, deploy it, and then by afternoon, 10 million people are using it. So you know immediately, is this working for them or is it broken? And even if you don't have 10 million people to try it out, ask 2. I think that there's a ton of value in that. So this one probably goes without saying in the Rails community, but I think the other way that we fight entropy is automated testing. I think it was Glenn this morning that talked about we kind of, in the Rails or Ruby community, are sometimes unreasonable about this. So we say, at all costs you must test, and I'm not by any means saying that. I'm just saying that if we want to figure out the balance between the risk and cost, testing is an important part of that. Glenn mentioned this, but I see testing really as an insurance policy. There are aspects of testing that help you design, and and go through that process of figuring out what to build. But for me, I do it so that when I change things 2 weeks from now, I'm not worried about if what I just wrote breaks. So some people will use the argument that testing takes too long or it's not worth it. And to those people, I would ask, why are we even programming in the first place then? Because essentially what you're telling me is that computers aren't good at automation, that it's inefficient to automate the testing of your application. So I think that's probably a poor excuse. I understand that there are certain constraints that you say, if I need to have this done by 4:15 today, I'm not going to have time to test it, and that's true. But I think in the long run, and even within days or weeks, I think testing pays off. All right, a little more audience participation here. Who is currently maintaining an app that doesn't have tests? How long has that app been in progress? 1 month? 6 months? I think you're the only one. You guys can admit it, it's okay. I realize it was your coworker's fault that it doesn't have tests, so you can give them this. Uh-oh. Lost power. Let's try this again. All right. So I give you a certificate for preferring to bungee jump without a cord. Come on up and get it. Set it right here. So the other thing that's harped on often in the Ruby community is dry. Don't repeat yourself. I realize these are simple and obvious things, but they're things that we violate all the time. Every time you copy and paste code, you're essentially doubling the amount of work that you're going to have to do next time you touch this software. I wish that I could say I never do this, but there's times where it just feels like, oh, this is just going to be quicker. I'll just copy and paste this. But don't do it. Does anyone have a coworker that likes to copy and paste code? Anyone? Anyone? Oh, Glenn, I saw that. Glenn, go back and give them this certificate. They only know how to code using the C and the V key. I'm going to set it right here. So this last point here is one that I need to hear pretty much every day. When I come across code that has been neglected, my inclination is to throw it all out and rewrite it. I spent 2 weeks, actually I didn't include this code. I spent 2 weeks recently rewriting a bit of code that sent notifications, so either push notifications or emails to users. And there was about 8 different places in the code where we were sending Apple push notifications, and then we wanted for certain users to send them an email instead. And so we started out, and I had a couple if statements. So if the user was using an iPhone, send them a push notification. Otherwise, send them an email. And a couple days into, I realized, okay, this is a really bad pattern. I have all these conditionals. Really what I need to do is I need to abstract this out into a notification class that then internally knows whether the user needs a push notification or not. So it took me 2 weeks to write this code that just sends an email. Like there was 8 conditionals that I would have had to add throughout the code and probably could have had it done in 2 days. But the point being, small incremental refactorings. Anytime you're going in to touch code, change one thing at a time and commit it. So if the method takes 4 arguments and you only want it to take 3, fix that. Fix any places within that method anywhere that calls it, and commit it. If you also want to rename the method, don't do it. Commit it, and then come back and rename the method later. So I realize those are kind of practical or seem like common sense, but I think those are important aspects. So there we go. We've defined good software. We've looked at what makes it go bad and talked about some simple ways that we can make it better. I want to give you a few examples of some code that I've seen recently or worked on and let you decide whether that's good software or not. So first one, method missing. couple years ago, a client of ours in Australia asked if we could come out and do a couple days of Rails training, and then at the end, help them evaluate their current Ruby code base. They had this GTK desktop application written in Ruby. So I got out there and did the training, and then about midway through the week, we started looking through their code, and one of the first things I came across was this. Has anyone done this?
There's an important application for that.
All right, let's hear it. There's an important application.
When you're doing security testing, authorization testing, you don't do exactly like that. You strip the thing all the way down so it actually returns that to everything. But sometimes when you're in the process of figuring that out, you realize what your result is before you're done. And it's easier just to return nil everything for the rest of the way out than it is to try to break your way back out with the response.
Okay, but so you still want it, anytime you end up accidentally with a nil object, you still want it to always return nil, no matter what you call on it.
I'm sorry, that's the actual nil class.
Yeah, this is nil class.
Oh, sheesh.
So, exactly. Yeah. So I asked them, I'm like, what in the world is this doing in this app? And they said, oh, well, we kept having problems where users would click on something and then the app would crash. So I said, okay, and so like to you, that was the acceptable solution. You make it so the app never crashes. Like, what did that gain you? Like, oh, well then, somebody will call us and say, yeah, I had a problem. When I click on this, it doesn't work. So this was basically their form of error reporting. Anyway, here's what you get when you do that. So nobody's ever seen anyone do anything like this? Come on, you have a certificate you could win. All right, take this to them. Can't tell good code from the broadside of a barn. Set it up here. So occasionally when we're writing code, we have to optimize for performance over maintenance. And I hate this point because I'm not ready to accept this, but there's been very few cases where we've actually had to do this. So this is some code that's in Words with Friends app. Basically, it's an XML API that talks to an iPhone client, or an iPhone client talks to the XML API. This method was getting called, I don't even know how many thousands of times a second. And when we did the benchmarks, we found out that we could actually save like 3 to 4 milliseconds if we coded the XML by hand. So we defined this on our active record model to call toXML. And this pains me. I still give the guy a hard time that wrote this every time it comes up. But I think, unlike the other example, the overriding nil, I think that this one actually still fits into the definition of good software. It's maybe not maintainable, it's not pretty, but it accomplished the task that we needed at the time, which was to decrease the response time by a few milliseconds. I lost track of time when my battery died. Does anyone know how much time I have left? Hours. Oh, 10 minutes. Okay, thank you. So another example, I'm one of the maintainers of Mongo Mapper, which is a Ruby mapping library to MongoDB. And last fall, we were working on porting a bunch of custom code that we had written to Active Model in Rails 3. And one of the challenges that we ran into was callbacks on embedded documents. So in Rails 2, if you wanted to define callbacks, the original code looked something like this. We had a creator update method. We'd run the before callbacks. If the result of whatever the save returned true, then we'd run the after callbacks. Rails 3, they changed this a little bit because, I mean, obviously this pattern is somewhat obnoxious because you have to do this anytime you want to add callbacks. So they made the API a lot cleaner. They made it so you could just pass it a block. Well, the problem with Mongo is that you can have embedded documents. So you have your root level record, and then inside of there, in the same record in the database, when it's stored, you can have basically a many association. Well, we wanted those callbacks to propagate down to those embedded documents. And there's not an easy way to do it with this because basically run callbacks does the before and the after, and we can't really inject into that life cycle there to run the same thing on each embedded document. So, well, here was the original run callbacks method. Basically, what we'd override the one that Rails defined, and we would loop over each of the embedded associations, send the callback, basically just propagate it on. So with Rails 3, we struggled with this for a few weeks trying to think of a way to do it, and we couldn't come up with anything. So initially, a bunch of the guys at Collective Idea, Chris Gaffney and Brian Reichbos, had already ported most of Mongo Mapper to Rails 3. But this was kind of the last piece that was hanging. And so one day I sat down, I'm like, okay, I'm going to figure this out. So came up with this little trick. It's a clever bit of code. I don't know how easy it is to follow, but basically we go over each of the embedded associations. We load them all up into an array, and then for each one, we inject a block that then creates another block that passes on that callback. It's clever. I mean, it works. The tests pass. The problem is if you have more than, I don't even know what the number is, maybe 100, 200, you eventually get a stack level too deep because we're basically creating one giant stack of these lambdas. So my question then is this good software or is this bad software? I don't know. For me, it hasn't broken yet. I've never had a Mongo document with more than a handful of embedded associations. So we've had a lot of people that have had issues with this and posted to the mailing list. So I think this is where the good software, bad software thing gets kind of difficult because it's not black and white. For me, this was good software to accomplish the task at hand. It cost me very little, just a little bit of time. And so far, there hasn't been a risk to me. Now, maybe someday there will be, but it hasn't happened yet. By the way, if anyone wants to fix this for real in Mongo Mapper, please do. That code is still in there. What was the question?
Go-to statements?
Yeah. Go-to statements. So anyway, I mean, that's my main point with this, that I think with open source, this gets kind of tricky because what meets my needs might not meet yours. It's a little bit of a challenge. So what do we do next? I guess what I'm asking you to do is be pragmatic. Good software is important. It's really important to me. It's something I've struggled with a lot. But it's not always clear whether it's good or bad. Software is design. I talked about this a little bit earlier, and I want to stress this. And one of the aspects of design, I think one of the most important aspects, is you embrace the constraints that are given to you. I think that's what good designers do. They figure out what the box is that they're trying to fit in, and they design things, they make them the best that they can to fit in that box. A lot of people are tempted to call us engineers, and while I think that we do things similar to what engineers do, I think engineering is really just a different application of design. And so there's things from engineering that we can take and apply, but I don't think we're just engineers. Earlier I used the word craftsman, and I think that the same thing applies. We're doing similar things to what craftsmen are doing. They're designing, but their constraints are different than ours. When I think of craftsmen, I think of somebody who ultimately the art is the most important aspect of that. And for some of our clients, it's not. So Glenn said in his talk this morning, sometimes you have to move ahead with weak evidence and weak conclusions because you don't have time to prove them. And I think that's one of the most important things in what we do. We have to sometimes guess, and sometimes we have to take a risk that we wouldn't normally take, but because of the constraints that we're given, we have no other option. So if we waited to write good software, we'd probably miss some opportunities. Like what if Twitter had waited until they could scale to launch? Where would they be? And I think we could probably come up with lots of examples like that. So be pragmatic is what I'm trying to say. All right, one more certificate left. Who here is working on an app that doesn't have any users? Meaning you haven't launched yet. How long have you been working on it? Anyone been working on it 6 months? A year? Nobody's been working on an app for a year?
I got one user, me.
Yeah, if we're our only users, that counts.
If you're your own user, that doesn't count. Is it eventually going to have more than just you? Someday. What's that supposed to mean? All right. For that, you earn this. I'm glad you like to polish turds. So I'll leave you with this. You can discipline yourself to write software that's good enough for your users, for future maintainers, for your own peace of mind. You'll find that you're more productive and your users are happier. So this is something I'm struggling with. I hope that you can struggle with it too and accept it. So thank you. Yes?
What's your position on worse is better?
What's my position on worse is better?
Have you ever heard of that?
I'm not familiar with that concept.
Worse is better is a whole thesis put up by the guy that had a list company, I think. But he was explaining how Unix beat Multics because Multics tried to solve this operating system problem perfectly, but Unix pushed a lot of the work back onto the programmers.
Okay, so
it was much easier to program Unix, the operating system, but the users were left with extra work forever after.
Okay, so the concept of worse is better is essentially like you make pragmatic choices now to get ahead. I generally agree with that. As the software developer and craftsman side of me hates that. Like I hate, when I'm actually writing code, I hate making those compromises. But when I'm able to step back, I think that that's the best way to go.
That's why Windows beat Unix too.
Yeah, Windows, yep. Any other questions or comments? All right, thank you very much.